David Kahn here with another question from your Hayes and Harris Math SL textbook. This is exercise 1H, question 2, part A. In this question, we're given a function and we're asked to find its inverse. We're going to sketch the function, its inverse, and the line y equals x. And we're also going to be looking at some composite functions using the function and its inverse. But before I do anything, what I'm probably going to want to do first is rewrite this to something more familiar. This expression is the same thing as the expression f of x is equal to 2x plus 5. Whichever form you prefer is fine, but I prefer this form. Alright, now moving on to part I. First thing I want to do is find the inverse of this function. To find the inverse of a function, what you have to do is swap the variables. Where you have an f of x, replace it with an x. Where you have an x, replace it with the inverse of f of x. So f of x becomes x. So x equals 2, and not x, but I'm going to swap it with the inverse of f of x, plus 5. So this is a function which describes, well, that is the function, and this is an expression which will give me the inverse of the function. All I have to do is rearrange it to solve for the inverse of f of x. So to do that, I'll subtract 5, and I'll get x take 5 equals 2 times the inverse of f of x. And then I'll divide by 2. X take 5 over 2 equals the inverse of f of x. I'm just going to put the inverse of f of x on this side. And I'm also going to distribute the 2 into the terms in the numerator. So x over 2 is half of x. And half of 5 is 2.5. Now, this would be normally fine. I just took the extra step because I know that I'm going to want to graph this function. And by dividing the 2 into the two terms, what I get is something that looks more familiar. This is the equation of a straight line. Y equals mx plus c. Okay, so let's get into graphing. I'm going to sketch the function, I'm going to sketch its inverse, and I'm going to sketch the line y equals x. And I'm going to do all of that on graph paper because I'm going to want to try and be careful with my sketch. So this is part 2. Let's maybe expand out this graph a bit, make it a little bigger. And we're also going to want to put some axes on the graph. Alright. So here's our y-axis, here's our x-axis, and we're going to draw the line y equals x. The line y equals x goes through the origin, and it rises at a rate of 1 to 1. So 1 unit over, 1 unit up, 1 unit over, 1 unit up, 1 unit over, 1 unit up. And it goes in the other direction too. 1 unit back, 1 unit down, 1 unit back, 1 unit down, 1 unit back, 1 unit down. So this is the line y equals x. On this same graph, we're going to draw f of x. F of x is 2x plus 5, so the y-intercept is 5 and the slope is 2. So we're going to go up to 5, 1, 2, 3, 4, 5. And the slope is 2, meaning we rise 2 for every 1 unit over. Rise 2 over 1. Rise 2 over 1. Back 1, down 2. Back 1, down 2. Back 1, down 2. We can start to see the trend pretty clearly. So let's go ahead and draw in the line. It should look like that. This is f of x. And then lastly, we want to draw the inverse of f of x, which is also a straight line. Its y-intercept, though, is negative 2.5. So we're going to go down 1, 2.5. The slope is positive 0.5, so we go up a half for every 1 over. Up a half, 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 1 over. Down 1, 1 back. Down 1, or sorry, down a half, 1 back. 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 And down a half, 1 back. And it looks like we're going to intersect at the same point that the blue line and the black line intersect. That's good. That should happen. We'll draw in the line. And this is the line for the inverse of f of x. Now, how did I know they should all intersect at the same point? Because for a function to be the inverse of another function, it needs to be the reflection of the function across the line y equals x. That's just all about what a inverse of a function is. It's like if you folded the paper along this line, the ink from this line would show up where on the other piece of paper? It would show up here. So the blue ink would bleed onto where the green line is. So of course they have to cross all at the same point. Right, part C says to show that the composite function inverse of f of x is equal to f of the inverse of f of x, and that they're all equal to x. So for part 3, they're saying find the inverse of f of x. So just to remind you, the inverse of f of x is 0.5x take 2.5, and f of x is 2x plus 5. So these are the two functions that we're going to combine. So the inverse of f of x then is the inverse of f of x. But x is an x, it's f of x. And f of x is 2x plus 5. We'll distribute the 1/2 into the brackets. So half of 2 is 1. 2 times a half is 1. And a half of 5 is 2.5. We still have the minus 2.5 over here. So x plus 2.5 minus 2.5 is x. The question also asked us to look at the composite function f of the inverse of f of x. So to do that, we'll go through the same process. F of x is 2x plus 5. We're not looking at x, we're looking at the inverse of f of x. The inverse of f of x is a half of x, take 2.5. We still have our plus 5. Once again, we're going to distribute into the brackets. 2 times a half is 1, and 2 times 2.5 is 5. Lastly, we still have our plus 5. And then x take 5 plus 5 is x. So we see that the inverse of f of f of x is x, and f of the inverse of f of x is also x. And so we can say that they're both equal to each other and they're both equal to x.